Okay, I forgot to do the participation for several lectures, so we're going to do it today. Let me actually check what's the news for. Yes. I'm sorry. This is my fault. Yeah, let's look at the news. Let's look at CNN. Okay, US. I will just say US, two words. Capital, US capital. So first, I have to turn on my server. Hold on 1 second. I have to turn on NG Rock. Okay, NG Rock is up. Now I can go Emacs minus NW EE1520 server CPP. Okay, and okay, so you see that is going to be capital US. Okay, it's up. It should be up. You can send it out. Yeah, it is quite interesting regarding what's going on in Washington, D.C. and how has been Trump administration in terms of their international um, relationship and policy. It's interesting. Okay, there's somebody missing a key. Okay, don't worry. We'll do it later. I'm going to get rid of my Firefox, get rid of my Zoom, get rid of this window, and I'm going to pull out my lecture today. So I'm go into one of the topics I traditionally I like to emphasize in object programming. This is called a virtual function. I'm going to start to introduce the concept virtual function. My first objective today is to communicate the idea of the concept called virtual function, what it is, and why do we need it. Okay, there are two issues. One is what is the mechanism called virtual function, and then we need to think about why we have this particular mechanism. Okay, so this is the diagram about a single inheritance between two classes, base and derived. By the way, I try to simplify the concept. And therefore, I use the example about only two classes here, base and the derived. But in general, you should have the capability, I trust you guys, to extend whatever concept I am going to present in today to multiple level, to a tree, to even more complicated cases. Okay. All right. So here is wait a minute. Why I didn't move? Why can I move? Ah, here. Okay. So first, I have to say, well, what's the difference between the regular member function? So in this case, in the base class, I have a member function called foo. I have a member function called foo. And also in the derived class, I have a member function called foo. You probably have seen that We've done that between person and traceable person and multiple things. But also, I have the other way to specify the member function. I add the keyword virtual in front of that. So in this case, I have a virtual member function too versus virtual member function. So this is just syntactically what's the keyword virtual. So if you remember, let me pull out the example. Is this the example? No, I want to pick up some better example. Let me go. Get rid of this. Okay, I'll use this as an example. If you go to, for example, person.h, you will see that I have a bunch of member function. For example, this portion, set home, get VSID, get name, get home, and operator overloading. Those are the regular member function because it doesn't have the keyword virtual in front of that. By the way, if you have a function, a member function that's being defined by the base class, in this case, person is a base, traceable person is the derived. So if in the traceable person through inheritance, they will inherit all the function, including virtual function, by the way, including virtual function. Inherit everything, but unless you override, you have your own version at the derived class, then by default, whatever derived class from this class person is going to use whatever implementation and design interface that's specified here through inheritance relationship. Okay, so those are just inheritance. But what I want to tell you syntactically, you see that I have two functions over here. I add the word virtual. I add the word virtual. That by syntactically saying that this two function, dump to JSON and JSON to object, those are the virtual function. Okay, I can, by the way, it's not just these two functions. I can make other functions also become virtual as well. Just in this example, only these two functions are virtual function. Okay, so just syntax, whenever you see a declaration of a class, and within the declaration that you have the virtual. By the way, I use the two word declaration and define or definition of the function. Specific, there is a difference. When I look at the .h file, here I just declare I have a class with this structure. But the definition of the class is actually under person.cpp. Okay, so I hope you separate the declaration. Usually I refer to the .h file or HPP file, and implementation or definition, that's actually in the .cpp file. And this concept is important to virtual function because I only need to say virtual in the declaration. And in the implementation, which is .cpp file, I do not use a virtual. In other words, if you only look at the .cpp file, you won't be able to tell whether that's a virtual function or not. You only can tell whether it's a virtual function in the declaration part of the class definition. Okay, so just let you know, if you want to read the file, you have to read the .h file or .hpp file to know whether it's a virtual function. That's the syntax part. Okay, now let's actually see what is the meaning of this virtual adding. What's the difference by adding this keyword virtual? So let me actually go back to the regular function. I have this is by syntax. You probably can see this is just a regular member function, non-virtual member function. I'm going to show you a piece of code here. I'm going to show you a piece of code. So now you see why casting is important. Now I'm going to do casting. So assuming the class is called my base and my derive, so I create an object called object1, which is based on base. My base object1, that means obj1 is my base object. And then my derive, I create another object called obj2. So obj2 is actually my base. So what I'm saying, you see that I'm actually calling foo. I'm using three different ways to call the foo. obj1.foo, meaning that I'm actually going to trigger or invoke the foo member function on my base object1 and object2.foo. And now I'm actually doing this. I'm doing this code is that I take object2 and then I cast with my base. So what is object2? Well, object2 is class, my derive. And then I actually cast .foo. Okay, the other thing I forgot to clarify is that for this foo function, I have a foo function implementation through my base. But I have another foo function, which I declare and define through the class my derive. Okay, so I have both. I have two different versions of the same member function foo. Okay, so I'm actually going to show you this code. So the result should looks like this. Okay, so the question is which foo function at runtime, when I really ask you the program, which foo is going to be called. So if you say object1.foo, then it's actually going to call my base foo because object1 is my base. Okay, the object belongs to this class. So when you call it, you should actually have that, right? Okay, so object2.foo, it should actually call this one because object2 is declared as my derive. Okay, so object1, object2 is clear. So this is a bit tricky. This is a bit tricky, meaning that, okay, I have object2. If I don't do the casting, I'm going to call just like the previous line, I'm going to call my own version of the foo. But because of the casting, I changed appearance about this object. So this object is really internally it's my derive, but because cast, what is a cast? Is wearing a mask. Okay, I'm wearing a different mask such that it looks like is my base. So now I'm going to call the function, I'm actually going to call the parent. So essentially casting is a way for you to control which member function to call. So that's why casting is very, very useful, very important, because remember, an object was created under inheritance hierarchy. It was created at one of the class called my derive, but you want to use some of the resources that's actually being declared by one of your ancestor or base class. Okay, remember to extend the concept from two to a whole tree. Okay, you can imagine that you can actually use casting to cast wherever you want to go. Okay, so this is clear that object1.foo is going to call the base, object2.foo is going to call the derive. But when you cast object2 with a base label, then essentially when you do the casting, it will go to the base. Okay, first I want to make sure you understand this. This is the regular member function. It goes this way. Does that make sense? The only thing you're probably not familiar with is the casting. Casting is very, very interesting. Okay, there is more interesting behavior about the unexpected, surprising behavior of the casting. This one is not so surprising. Okay, it's fine, but you should know. Okay, this is a very useful tool for you to do object-oriented programming. Okay, any question? Okay, so now I'm actually going to ask you the same question. I'm going to show you the same question, the same piece of code. Okay, the same piece of code, but the extra keyword virtual. So this member function foo was defined as a virtual member function. Okay, it's a virtual member function. I mean, later you will ask me, but what do you mean by virtual? Why do you actually use this keyword? We'll get to that, but until then, all right. So now I want to ask you the question. Okay, it's a bit tricky. What should be the first one is call? Okay, not surprised. By the way, virtual function is virtual, but it's not, it doesn't change that much. If your object one.foo, it will still go to the base. Okay, the first line is not surprise. If you want to call, regardless is a function or virtual member function, when you declare you want to get a call, it will actually call whatever the original class. The second one is actually going to call, not surprise, this one as well. So the first two lines, it will be the same. But the third line is going to be different. Okay, so the first two lines is the same, but the third one, when you casting object two, I'm actually still calling the derive. Okay, first, you have to know the difference. When you call the virtual, it seems to me a little bit different when you do casting. You can have a multiple interpretation, but I want you to think about, just look at the behavior difference between this one and this one, okay? So I'm actually giving you the behavior. I haven't explained to you exactly what had happened here, but I'm actually telling you that that's behavioral difference between adding the new keyword virtual and without. So what's your interpretation about the difference? I know most of you probably never use virtual function, and you probably don't know how virtual function is implemented. By the way, my excitement in teaching, which is when I say excitement about teaching or instruction, that means students suffer, okay? So my excitement about teaching this subject is that I actually go in later into the memory to actually see how virtual function is implemented. Then you will know that why this will have this behavior. I will go deep into that because I think it's a very valuable experience. Even most of you probably hate it. Okay, but I want you to guess why, how do you actually try to provide some explanation about what is the virtual function is doing? I mean, how do you interpret this difference? Even though you don't know the implementation, you never heard about C++, when you see the difference, what's your reaction to this language design? Okay, the first way to interpret this is saying that, okay, wait a minute, it seems to me that casting is ineffective in changing the behavior between the base class and virtual class. So if you do this, then essentially, no matter how I do casting, I'm actually still calling the same function. By the way, I want to show you, I suddenly realized in virtual function, I can still do the kind of control, but I have to do it differently. Let me actually tell you what you can do. In fact, I showed this example last time. If I really want to do to call my base in the virtual function, what I will do is obj2 dot, I believe is my base, colon, boom. Let me put this obj2. If I want to treat it as a different way, if I really want the code to call one of the version in the base class in the inheritance hierarchy, I can still do that in the virtual function. I can just say obj2 dot my base colon foo, which basically I explicitly to tell the compiler I want to invoke that particular version associated with the class my base. okay? But I'm actually going to focus on this line right now, but this is the core. If you understand this example today, you will feel really smooth when you want to deal with a lot of virtual function issue, okay? So this is my base, object two, dot foo. It's actually going to call this, even though you try to do the casting, okay? Okay, any guess about what? Okay, what I'm going to tell you is I'm going to tell you the definition about the difference between member function and virtual function. So let me actually go to the definition first. So the core question I want you to think about is that when you call a function, you really want to, what do you mean by call a function? When you, let me put a different way to explain it. If you want to call a function, you must know where is the entrance point about that function, right? You want to call a function, say you want to call the function foo or any function, even in C programming or Java programming, Python. It's always when you call a function, you need to know the entrance point about where that function is. So when you say, okay, I want to call a function foo, how do I determine where is the foo, the entrance point about the function foo? In regular function, this regular function, including non-object-oriented language, usually is that when you want to call this function, I have to look at this particular line, because I'm going to make a call. So I want to know, okay, what's the data type about this line? Because this line, if it's object2.foo, then object2, I know it's the data type of class derived. So therefore, I know, and when I call this line, I know this must be class derived foo implementation. So is at the time when you make the call, you have to see that particular line. What's the type? This type is object2, so I know. Okay, but this is a little bit different. This is the casting. So what does casting means? Casting means I change the type at this particular time or this particular line. And therefore, when I change the type, then the foo is going to be associated with a different type. So essentially, what we're saying that how do we determine what is the entrance point about that function call is actually determined by the class type that we see in the code at that particular line. Okay, so I said this, but I want to ask you another question. Okay, let me first say this and then ask you the question. I said, well, how do you determine it's a regular function is the reference class type of the object at the time of the call? At the time of the call is being here, right? At the time of the call, then I want to decide what is the entrance point. Okay, this is the regular function call, regular member function. Okay, so I want to ask you another question. When I say at the time of the call, I'm wondering, compiler in this case is G++. Do you think at the compiler time, the compiler G++ know how to find the correct function entrance when they look at your program? Meaning that can the compiler help to decide that whether the foo is belong to the base or the foo belongs to the derived? If you think yes, please raise your hand. If you say no, please raise your hand. Okay, the answer is a yes. The compiler will know. Okay, this is a bit tricky, but I want to tell you that this is important because I want to separate C++ is such a language we need to separate between what we call compiler time and runtime. Compiler time is looking at the source code, generate the executable. And runtime means that after you have the executable, you start to execute the program. That's runtime. Compiler time, runtime. Okay. So this one I can actually determine at compiler time. So it's tricky. Is even though I said at the time of the call, but I can actually determine at the compiler time. Why? Because I look at this piece of code. I look at piece of code is object 2, right? This is object 2.foo because compiler must know what is the data type for object 2. The compiler need to know because it need to know, see this line, how this line is declared. So therefore, the compiler will have knowledge about obj2 as a variable, and the compiler will track the information, know that obj2 is belong to my derived. So compiler know obj2.foo is actually the derived foo. Okay, so compiler I can determine. But let's look at the casting. The casting compiler know this as well. Compiler will know that obj2 belong to my derived. But compiler also know the meaning of casting. So compiler will do a conversion to convert the data type of obj2 or generate code to do the conversion in situation that's needed, and such that compiler know the whole thing between this pair of parentheses is actually belong to the type my base. And since compiler know this is the my base, compiler certainly know that my base has this member function called foo and know where is the entrance point. Because compiler will do code generation and compiler know how to bind this code together. So the whole thing is actually compiler time issue. So regular function is always compiler time issue. I mean, there are very, very few examples that compiler didn't have the knowledge to make a decision. They have to delay that until runtime. And we will address that, which is virtual function actually. But in the regular member function, the compiler can always resolve where the function is. So that's why compiler with regular function, they can do, for example, optimization about code generation, such that. Okay. Okay, so I want to tell you a few things you should learn. Number one, that a regular function, how do I determine which function I really need to call? Is a compiler's call. Compiler can decide that. Okay. Now we look at the different thing. So what is a virtual function? Here's a definition. The definition says that the reference type of the object at the time of the creation. Meaning that I'm not looking at how you casting the object, but I'm looking at when this object was created, what was the data type for that object. So why is this case? Now you look at this at the time of creation. At the time of creation, this line is the time that this object was created. Is my derived object 2. So I know object 2 belongs to my derived. So I'm looking at the reference class type of the object, which in this case is our obj2 at the time of a creation. So regardless how you cast this, but at the time obj2 was created, it was my derived. So therefore, I will always treat that as my derived. And therefore, I will determine when you do this casting, I'm still calling the member function. Okay, that's how it really is. So at the time of the object, at the time the object was created, what was the data type? That will determine how virtual function is going to call. So that's why no matter how you do that, I'm still calling the my derived version of the member function. Okay, so now I want to ask you the following question. I already told you this one compiler cannot determine. This is tricky. The compiler, in fact, cannot determine what was the data type that was created associated with any object. I can give you a very simple example. In this example, the compiler might be able to know, right? because it's in the same function. The compiler will know, okay, here you're using obj2, and then I know obj2 is actually my derived, was created here. This is the line the object was created. So therefore, the object was actually created, so I can actually do that, right? I can do that. But is that always true from the compiler's perspective? Probably not. Let me show you an example. Let me show you an example. Let me create a new slide. Let me move this thing somewhere else. Can you see this? No, I don't want to see this part. Okay, fine. I'm going to let it stuck there. So I have a two type of object. This object is called, I call a person. And I have the other kind of object, which is I'm going to change the color. Let me change the color to green. And then this one, I call a traceable person. Let me make it a little bit bigger. So we have two different classes. Two different classes, person and traceable person, just like exactly like what we have defined. Okay. And then what I'm going to do is that I have a vector. Let me actually write something. Go back here. This one. I have a vector of person objects. Okay. And I'm going to create. This is called person. I will use a different color. Let me do it. No. I want to do this part. Can I do something over here? How do I change this? No, I don't want to. Wait a minute. I lost it. Drawing. Where's the color? I can change the color. Why is it different? Okay. Can I do this? Color. See, I always lost my interface. Okay, fine. I'm just not bothered with that. So I'm going to do a question mark. The reason I put a question mark is because I don't know that that particular object was created as a person or as a traceable person. Okay, I think I have this. And then I pass to another function. Okay, I think this is a good example for me to explain what's the situation. It's a little bit deeper, but I hope this simple example can motivate you to understand that why this is not a compiler, the issue that you can resolve in compiler time. So I create a vector of person object, and the thing is that I really want to keep an array of a lot of person. But the thing is, I realize in my application, some of the person object I was created using the person class, but some of the object was created using traceable person. And this is the base, this is the right, and I create a bag of person, and some of them was person, and some of them was traceable person, I don't know. But I put it into an array. When I want to pass to another function, I kind of say, okay, I have a two different type of object, but I can always casting or convert them to the base. So inside the vector, or array, if you're a C programmer, that is essentially they all looks like is a person object. But it's possible that some of them, you don't know whether that's true or not, because it was determined at the creation time. So you pass into another function, which with a vector of an array of a bunch of person objects. And now that's tricky, because now at the time when I decide I have an array, go through each of the person, I'm going to call that function foo. And then when I look at this person, I actually don't know whether this person was created as a traceable person or person, because that until the runtime, until I know, I might have a reading this from a file. Okay, it was a JSON format. I'm reading a JSON, decide whether I want to create a person or I want to create a traceable person. So I actually didn't know that until I see my input to the program. And from the compiler perspective, it only know that this is an array of person object and it's a virtual function foo. And I know that whenever it's a virtual function, it could be one of the derived class. In fact, the design is to a point when you compile the program, maybe after you compile the program into the .o file. By the way, this happened. After you compile the program into the .o file, somebody add another derived class and then have another piece of code. And they generate an array. And they can actually pass over here, let you to run. Okay, in fact, it's to that point, meaning that that class, the compiler doesn't even know exists until after the compiler handled this piece of code. Okay, this is a bit tricky, but if you're mixing the compiler time, runtime, you start to think about, oh, wait a minute, the compiler has some limitation in terms of the information they can handle. Okay, so using this example, I hope I illustrate that why sometimes compiler cannot determine what is the original class that this object was created. Okay, any question? Okay, I know this lecture might be intellectually kind of strange, okay? Because virtual function itself is not an easy concept to understand. Okay, so now let's go back to this one. So I have this two difference. If it's a member function, it basically say at the time of the call, if I can determine the type, then that's the type I'm going to do. So basically, this basically say, hey, fine, compiler can know that. At the time of call in my code, what's the data type? That's it. But if you add a virtual, I have to look at the time of the creation, the time when the object was created. When the object was created, what was the data type? And I make a simple argument in the previous slide. I said, this is definitely not the compiler time, because at the time of the compiler, when you compile the code, there's a lots of information that's unavailable to the compiler. So therefore, you have to wait until runtime to make that decision. Okay, so that's the virtual. Okay, let me just go back to, I just want to make sure you understand this slide, because this is the example. Sometimes programming language, you have to learn through example. Using this example, you see the difference. Then gradually, when you see more information, you actually will learn the whole thing. So I wanted to make sure you understand that when you declare a virtual function, no matter how you do casting, the function is going to be determined at the creation time. So when you actually determine this is the creation time when the object was created, then which function I'm going to call is already decided. Okay, this is like that. A regular function, I can only look at this line. I will know that which one to call. That's number one. Number two, which is very important, I want to tell you, is that to determine which function to call for virtual function is not a compiler time issue. Compiler cannot handle that. You have to wait until runtime to handle, which means that we need to have a runtime support in order to handle virtual function. That's why I need to explain to you how virtual function is implemented, because it was not a compiler time issue. Okay, any question for now? Okay, so let's look at the example, and then we can do some of the interesting example next. I have about 4 minutes. Okay, right now you can see that I have a two object. I want to let me make this here. So let's look at this two line. This is already available under the master directory. I declare a object out of label GPS, which is LG1. And then I declare, and I actually create another object called gcopy. But that gcopy, when it was created, was GPSDD. But I did a copy of the content of LG1 into gcopy. So I have two objects. How do you determine the creation time? You have to look at this particular portion of the first line, label GPS LG1, which means that this object was created as label GPS. And then I have another function, another object called gcopy. It was created as GPSDD. When it created, then this object was the original determined. So before you even look at the rest of the code, you already know from the virtual function perspective, the first line will go with label GPS. The second line will go with GPSDD. So in terms of the virtual function is already done. And then this part is just assign. Once you create it, I change the value. I'm using LG1 to change this value. Okay, I'm using this as an example. And now we have to look at the function. For example, you have a function called lg1.dump.json. That is a member function, and this member function is a virtual by definition. We're going to see how we can change that. And also, I also have the other function, the other line over here, which is a gcopy. I actually do a casting about this copy over here. So this is another way when I do this, okay? So I'm going to show you this example. We're going to change code here and there to see the difference. And hopefully through this example, you start to get a feeling about what is a virtual function, okay? All right, so let's stop here, take a 10 minutes break, and then we come back.